talking about the algorithm earlier, the thing that was used to decide these A-level and GCSE results in the first place that hasn't worked the way it was supposed to. We were asking whether this was foreseeable, whether it was even preventable altogether. Before we came on air, and before the government announced its U-turn at 4 o'clock, I spoke to Tom Haynes. He is an expert in statistics and a lecturer in machine learning at the University of Bath. And he actually explained that algorithm for me, how it works, and in particular why it might favour certain schools.
When you get to the small class size, what happens is essentially the algorithm doesn't work. And so it switches over to using the teaching grades when the classes are really small. And the result of that is the teachers tend to be a little bit optimistic, so you get slightly higher grades given to the students in small classes.
OK, and that by its nature would favour students in fee-paying education because their class sizes are often smaller.
Exactly that.
Right. And why was the algorithm designed this way? Because as you explain and describe it there, it seems fairly obvious that it's not fair across the board.
Yeah, it's almost like we're at the stage in designing algorithms of this nature where construction people were a few hundred years ago when they just threw up a building and said, looks good, we'll leave it to stand. Now in AI, we're at that stage. We're not yet at that point where we're really checking these things. People haven't got into the habit of realizing that validation, that checking, that ensuring that it's going to do the right thing is actually more important than just getting it working in the first place.
Do we have the expertise and the technology to create an algorithm that would have worked and been fair to everybody?
Would have worked, yes. Been fair in the sense that everybody would have got the same treatment, yes. Whether you consider everybody getting the same treatment to be truly fair is sort of an ethics issue, so yeah, I wouldn't want to say more than that.
No, I see what you mean. But it's not that this is beyond the realms of the technology that exists to actually get this right.
Yeah, many of the problems they've made, there are known solutions to that could be deployed. And ultimately, I think the main problem is they just didn't ask for help. Plenty of people would have been happy to give it.
Well, this is an issue that we're really getting into now. So if you, Tom, had the chance to look at this a couple of months ago, would you have been able to identify this problem?
Yes. I didn't even have to see the data. This was one where I read their report and I was able to spot the problems just based on the descriptions and the maths.
Right. Because we've also been told, this programme's been told by the Royal Statistical Society that they did offer two of their qualified fellows to look over this and assist, and they were told that if that was going to happen, they would need to sign a non-disclosure agreement, which would mean that the fellows couldn't talk about the model and what they thought of it in public for very many years afterwards. Are you aware at all of anybody being approached to try and help with this, to try and provide some independent guidance?
I've heard exactly what you just said from the Royal Statistics Society, but I know of nobody else who was approached. They were offered help and they said no, and I think that was a mistake.
Mm. And obviously, Tom, you weren't involved in the designing of this and you weren't involved in the execution of this, but from your perspective, it looks like a real mess, doesn't it?
Most of the students I teach could have done a better job. Most, not all of them. But, I mean, I don't want to be too harsh. Obviously, circumstances were hard and there has to be some allowance for the difficulties of working under these conditions, particularly with data that is very confidential. You can't just hand out student data to any old person or just send it off to someone's house. But doing a better job was entirely doable.
That is Tom Haynes, who's an expert in statistics and a lecturer in machine learning at the University of Bath. Thank you very much for all of your texts and your tweets and your thoughts. We'll do some of those very soon. It's Drive. It's 6:32.
On digital.